Here in this video, we are going to solve traveling salesman problem by branch and burn method to reach a single tour. ஸோ ஒரு ட்ராவலிங் சேல்ஸ்மேன் ப்ராப்ளம்னு சால்வ் பண்ணும்போது நமக்கு 2 டூர் கிடைக்கும்போது அது ஒரு டூராக சிங்கிள் டூராக நம்ம வந்து எப்படி ரீச் பண்ணலாம் அப்படின்றத இந்த வீடியோவில் பார்க்கலாம்.
கொடுத்துருக்க ப்ராப்ளமை ட்ராவலிங் சேல்ஸ்மேன் அந்த மெத்தட் யூஸ் பண்ணி வில் ஃபைண்ட் எ டூர். அந்த டூர்லேருந்து ஹவு டு பிரான்ச் அண்ட் பவுண்ட் இட் டு ஃபைண்ட் த சொல்யூஷன் அப்படிங்கிறது தான் அந்த மெத்தட். ஸோ ஃபர்ஸ்ட் இனிஷியல் சொல்யூஷன் என்ன அப்படின்னா, by using traveling salesman that has been studied in our undergraduate course of BSc Mathematics, right? So the solution first will be done by traveling salesman method. Okay, right. So usually நம்ம என்ன பண்ணுவோம் அப்படின்னா, ஃபஸ்ட் என்னென்னா ஒரு ரோ எடுத்துக்குவோம். ஃபஸ்ட்டு ரோவில் இருக்கிறதுலே மினிமம் எலிமெண்ட்டு, இதில் மினிமம் எலிமெண்ட் அப்படின்னா 3. ஸோ அந்த 3யை இந்த ரோவில் இருக்கிற ஒவ்வொரு எலிமெண்ட்லேருந்தும் சப்ட்ராக்ட் பண்ணிடுவோம். ஸோ அப்படி பண்ணும்போது இந்த சொல்யூஷன் எப்படி மாறணும் அப்படின்னா, அதாவது இன்ஃபினிட்டி 10 3 6 9 5 இன்ஃபினிட்டி 5 4 2 4 9 infinity 7 8 7 1 3 infinity 4 3 2 6 5 infinity. ஸோ இப்போ நம்ம சப்ட்ராக்ட் பண்ண போகிறோம். ஸோ இது எதுக்கு ஈக்குவலாக இருக்கும் அப்படின்னா, ஒவ்வொரு ரோலேருந்து இப்போ ஃபஸ்ட் ரோவில் 3, இப்போ இன்ஃபினிட்டி மைனஸ் 3 அகெயின் இன்ஃபினிட்டி தான். 10 மைனஸ் 3 7, 3 மைனஸ் 3 0, 6 மைனஸ் 3 3, 9 மைனஸ் 3 6. அண்ட் அதே மாதிரி செகண்ட் ரோவில் மினிமம் எடுத்துக்கிறோம் 2. ஸோ இந்த 2வை ரிமைனிங் இருக்கிற எல்லா எலிமெண்ட்ஸ்லேருந்தும் நம்ம மைனஸ் பண்ணணும். ஸோ 5 மைனஸ் 2 3 இன்ஃபினிட்டி 3 2 0. அண்ட் அதே மாதிரி தேர்ட் ரோ. ஸோ தேர்ட் ரோவில் மினிமம் எலிமெண்ட் இஸ் 4. ஸோ 4 மைனஸ் 4 0, 9 மைனஸ் 4 5 infinity 3, 8 minus 4 4. அதே மாதிரி இந்த ஃபோர்த் ரோ இதில் மினிமம் எலிமெண்ட் 1 அண்ட் 1 சப்ட்ராக்ட் பண்ணிங்கன்னா 6 0 2 infinity 3. and the last row is the minimum element is 2. so 3 minus 2 1 0, 6 minus 2 4, 5 minus 2 3 and infinity, right? now நம்ம நெக்ஸ்ட் ஸ்டெப் என்னென்னா, இப்போ ஒவ்வொரு ரோலுமே நமக்கு ஒரு 0 வந்திருக்கும். இதே மாதிரி ஒவ்வொரு காலமும் வந்துச்சுன்னா அடுத்த ஸ்டெப் போகலாம். இப்போ இந்த காலத்தில் 0 இருக்குது, சேஞ்ச் பண்ண வேண்டாம். அண்ட் இந்த காலத்தில் we have 2 zeros, ஒரு 0 இருந்தாவே போதும். அண்ட் இங்கே 0 இருக்குது, இந்த காலம்லேயும் 0 இருக்குது. ஸோ ஃபோர்த் காலமில் 0 இல்லாதனால ரோக்கு செஞ்ச மாதிரியே we are going to do for this fourth column. so we are going to take the minimum element from this column and subtract that element, minimum element from all the elements of this first column and then second column, and we'll go for the third, and now we'll have the fourth column. so fourth column should be changed, right? so 3 minus 2 is 1, 2 minus 2 is 0, and 3 minus 2 is 1 infinity 3 minus 2 is 1. and fifth column will be as it is. there is no change since there is a 0 in this column. now we need to allocate, now we need to check whether there is a 0 in each row and column. so we have 0 in first row and second row, third row, fourth row, fifth row, and similarly zeros are in each columns. now we are going to allocate the 0 for each row and column. okay, so first start with the first row and I allocate this 0 and while allocating we need to cancel the remaining zeros in the same row and column. There is no zeros in the row and column. We'll move on to the second row. There are 2 zeros in the row, and I'm selecting this 0. I'm allocating this 0, and I need to cancel the other zeros in the same row. So here I have 1 0 here, so I'll cancel this, and there is no 0 in the column. Moving to the third row, we have here 1 0, so we'll allocate this 0, and there is no 0 in the row and the column. And the fourth row we allocate this, and we'll cancel the 0. There is one more 0 in the same column, so we'll cancel this, and there is no 0 to allocate in the fifth row. Now there are 1 0 allocated in each row, and there is no 0 allocated in the fifth row. And similarly for column, there is no 0 allocated in the fifth column. So now we are going to do the next step so that we can have allocated zeros in all rows and columns. Okay, to do that we are going to cancel all the zeros using minimum number of lines. Okay, right. So in order to that, we are going to use minimum number of lines to cancel all the zeros. So we have 1 0 in the first row, 2 0 second row, 1 0 third row, and 1 0 in fourth row, and 1 0 in the fifth row. So the maximum zeros in the row is second row. Similarly, here 1 0, here 2 zeros, and 1 0 1 0 1 0, right. So first we will cancel the row or column with maximum number of zeros. So the second row has 2 zeros and second column has 2 zeros. So we'll cancel these two first, right. Now how many zeros we have remaining to cancel? Here 1 0 and here 1 0. Now we can use any horizontal line or a vertical line to cancel this. I use a horizontal line to cancel, and you can use even vertical line to cancel this 0, so there is no problem at all. And similarly I use a vertical line to cancel this 0. Now we are going to change this matrix here by doing a little change. What you're going to do is you're going to select a minimum element from these remaining elements. Okay, so by considering this 3 by 3 matrix, the minimum element is 1. So this one will be added to the place where we have plus sign. Shocking. Actually, I'm saying that this one should be added where we have the crossed lines, intersected lines. So these 4 are the places, but these 2 are infinity, so we don't there is no distance related. We don't need to add here, and we need to add here 1 to these 2 places. So here 1 will be added, this will be 8 and this will be 4. Okay, and that the same 1 should be subtracted from the remaining uncancelled elements, that is from all these 9 elements. Okay, so now we will do the change here. So first we need to add here this 1 to 7 and 1 to 4. This will be infinity, 8, 4, infinity. Okay, right. So now the remaining elements will be as it is. So 0, 1, 6, 3, 0, 0, 0, 6, 1, 5, 0, 0. And 1 will be subtracted from these elements, so we'll have infinity, 0, 3, 1, infinity, 2, 3, 0, infinity. Okay, okay, right. So now we are going to have we are going to allocate the zeros now. Okay, the same procedure we are going to follow. First, allocate 0 for the first row, only 1 0, we'll choose this 0, and we need to cancel the remaining zeros. So if there are no rows, there is no zeros in the row and the column. Move on to the second one. Second row, we have here 2 zeros. We can select either this or that. Let me select this, and here we have 1 0 in the same row, so we'll cancel this, and 2 zeros in the same column. We also need to cancel this. Okay, right. Now we are going to allocate for the third row. So this row 0 will be allocated, there is no 0 to cancel, and the fourth row we have to allocate this. And listen, here we have, if we allocate here, then this is the 1 0 we have. Okay, so this is for your clarification. So now if we choose this 0, if we choose this 0 instead of this, then these zeros will not be cancelled. So I will have 1 0 for the fifth row. Okay, so let me choose this 0, right, and I'll cancel. There is no 0 to cancel. Now these zeros will be there. Okay, so for your clarification I did this. Now you might be very clear to before cancelling your zeros. Now so if we choose 0, there is no zeros here. Next, if you choose 0 0, this 0 will be cancelled. So this will be cancelled because of this. And if you choose 0, this will be cancelled, and this 0 remained there to allocate for the fifth row. So, and I hope you understand now. Okay, so now this is our allocated zeros was 1 2 3 4 5. Okay, so now we might be very clear. Okay, now we need to form the tour. Since we have each 1 0, at least 1 0 in all the rows and all columns. First row, second row, third row, fourth row, fifth row, and first column, second column, third column, fourth column, fifth column. So now we can do the tour. Okay, so for tour you need cities. Let me name that as A, B, C, D, E, and here A, B, C, D, E. To write a tour, we will start from the first city A. So from A, the A row, the allocated 0 is 0 here, third column, and it belongs to C. So from A to C, and so to C, now from C to where? So C to, again the tour ends here because this 0 belongs to A. C goes to A, the tour ends here, right? Okay, so what is the procedure now? Now we need to start from second city B. Let us start from B here. So in B the allocated zeros here 0, and it is eth column, so it is E. And from E we have the allocated 0 is on D. So from E we need to go to D, and from D we need to go to B, right? Okay, so now we have tour, but it has been split up. Okay, so a traveling salesman problem main objective is start from a city to visit all the city once and reach the same city, but this objective is not met here, and therefore by using branch and bond method we are going to make a single tour. Okay, now let us know how to do that. Okay, now we are going to consider the small tour of these tour. The small tour is ACA. Okay, now we are going to split it up. Okay, so the subtour, this ACA, is disrupted. So this will be disturbed, right? Disrupted when we impose, or if we impose the restriction. There is a restriction. What it is means, the restriction XAC and XCA. So 2 0. Okay, right. So now we are going to target this subtour. We are going to target this subtour. So targeting subtour ACA, targeting the subtour ACA, we can make 2 branches, right? So yes, we are going to make branches. So surprisingly, our problem 1 is, we know the problem 1, and we are going to make 2 nodes. Okay, so the first node will be the problem 2, with the node with the distance that is DAC equal to infinity with this. And next problem, the third node will be DCA equal to infinity. Yes, so these two will be there. So targeting the subtour, we are breaking two branches are made, right? So the two branches, that is x13 equal to 0 and x31 equal to 0 are made. So we have also made the two nodes. The first second node, the node 2 is being created. The node 2 is being created by subtour DAC. Sorry, this is ACCA. Right, DAC equal to infinity and node 3 by DCA equal to infinity. Now, so this is first problem. We know now we have created second problem and the third problem. Okay. So before going on to the problem 2, let us find the distance, the z value for the problem 1 by using this subtours. Okay. So what will be our value of z? So to know this, we need to calculate for A to C distance from the problem. So here we have A to C. A to C is 3 and C to A is 4. So 3 plus 4 here. Actually this is 3, this is 4. Okay, right. Now here and then BE, ED, DB. So here we have here BE is BE 2. So BE is 2. ED, E to D is 5. So it is 5. And D to B is 1. Now we need to add all this. So your Z value is equal to, I have to write here, then I will write here, Z equal to 3 plus 4 plus 2 plus 5 plus 1. So if we add all together 15. So you'll get the Z value is 15 here. So it is Z value 15. Now we need to find the Z value for these two. So now consider the problem 2 with the distance as infinity for A to C. So now what you're going to do is, we are going to create a problem 2. You are going to create the problem 2 by substituting infinity for A to C. That is, in the main problem, the first problem, we are going to allocate infinity. A to C is here. So this
problem to the continuation video link description irukku. So we will see in the next video. Thank you.